This tutorial will show how to test the high set of an overcurrent relay with two elements. The pulse ramping module has been specifically designed to test the pickup value of protection relays with more than one element. Pulse ramping means that the current is not increased continuously, but in a sequence of short pulses, to prevent the first element from tripping. As shown in this figure, the first element trips at 1.8 amps with a delay time of 500 milliseconds. The second element trips at 6 amps with a delay time of 100 milliseconds. The idea of testing the pickup value of this last element by continuously increasing the current will fail to work because the first element will always trip before reaching the second element. By ramping the current in pulses shorter than 500 milliseconds, it is possible to prevent the first element from tripping and gradually approach the second element. To do this, we insert a new pulse ramping module in our OCC file and we apply OMICRON's Ohm's law. Since we are testing the high set of the overcurrent protection function, we need to increase the maximum current allowed in the test object. Otherwise, it will not be possible to reach 6 amps. Regarding the hardware configuration, we activate 3 currents and the trip contact. It is not possible to use the pickup contact because this signal will be active at any time after reaching the first element. None of the other signals are needed. The test view window is composed of 3 tabs. The first tab, Ramp Parameters, contains the parameters of the ramp and the measurement conditions. The signal and quantities to be ramped need to be selected from the drop-down menus. In this example, we will simulate the variation of magnitude in a 3-phase fault. Similarly to the ramping module, the ramp signals are disabled in the fault state table. With regards to the ramp settings, a pulse ramp always starts with a pre-fault state in which the reset values are applied. Since the duration of this state is not critical in this example, we can keep the default value. The pre-fault state is followed by the first pulse that starts at the value indicated in the from field. The pulses will be increased by delta until the end value is reached. To determine these settings, we will follow the same theory that we recommended in the ramping module. The ramp will range from 80% to 120% of the high set value. As delta, we will take the current tolerance from the manual divided by 4. Then, the start value will be 4.8 amps. The end value, 7.2 amps. And delta, 45 milliamps. The rest of the parameters to be output during the pulses can be defined in the fault state table. Balanced angles and a frequency of 50 Hz are set. The fault state must be shorter than the trip time of the first element, but it must last longer than the trip time of the element you want to test. Therefore, it has to be a middle ground between 100 and 500 milliseconds. Let's say, for example, 300 milliseconds. In order to measure the high set, the reset value must permit the relay to drop off. The reset state will be applied in between 2 pulses during the reset time. To avoid any confusion, the current has been set to 0 and the duration to 100 milliseconds. This is long enough for the relay to drop off between 2 pulses. In the assessment section inside the test view, the measurement conditions can be defined. First, the contact to be monitored, in this case, the trip contact. Then, the nominal value and tolerances. The expected pickup value is 6 amps. To enter the tolerances in percentage, check the relative tolerance box. In our case, 3%. The pulse ramping module will automatically assess the test results using these values. Have a look at the state phasor view to see a graphic representation of the settings made for the reset state and fault states. Switching to the Binary Outputs tab, the conditions of the binary outputs for the reset state and the fault state can be determined. In the General tab, we can define how the test should be started and stopped. By choosing Immediately, the test will start as soon as the Start button is pressed. The binary input option starts the test by the occurrence of a trigger signal at a selected binary input. The last option is used for GPS-synchronized end-to-end testing. For this test, Immediately will be the starting option. This checkbox lets you decide whether the ramp should be stopped if the measurement condition is reached, and here we can set a delay time for the stop. Start the pulse ramp by clicking on the Start button. Check the Time Signal View window to visualize the pulse ramp or the recorded binary inputs, and the Report view to see an automatically generated report of the test.